This is Chapter 1 for Matho 306. Chapter 1 is all about integers, and our first unit is all about operations. So first we're just going to start with the basics of numbers, place value, positives and negatives, just kind of refreshing our memory on all of those, just real basics. Then we'll get into operations on integers. So section 1.1, which means Chapter 1, Section 1, is on place value, and we need to know 5 sets of place values. And I think you'll be familiar with these once we get started. The first place, all the way to the right, the very first place value, is the ones place. Then we have the tens place, and then we have the hundreds place. So ones, tens, and hundreds. The first set of 3 is all considered ones. Then we have a comma. After that comma, we have the thousands place. Then we have the 10 thousands place. And we have the 100 thousands place. And sometimes you'll see that first place called the 1,000s place. 1,000, 10,000s, and 100,000s. That whole set of 3, the second set of 3, is the thousands. We like the 6 digits. That's what they mean by 6-figure salary. 1, 2, 3, 4, 5, 6. We all want that 6-figure salary. The next place is the 1 millions. And then we have the 10 millions and the 100 millions. So it goes in that same order, 1, 10, 100. And this set of 3 is the millions. And so we always want to win the lottery and win millions. After the millions, we have the billions. So we have the 1 billion, 10 billion, and 100 billion, that same pattern. And this set of 3 is the billions, which is a little unreal for us. I know some people have billions of dollars. I know our national debt is at least in the billions. And then the next set we need to know is the trillions. So we have 1 trillion, 10 trillion, and 100 trillion. Which again seems kind of unreal, but it is the trillions. There are prefixes. This MI prefix is singular, like 1. BI is double, like 2 billions, and then tri is 3. So they do have these prefixes to kind of help us remember the order: millions, billions, trillions. So those 5 sets of place values are what we need to remember. I think it's pretty straightforward. Your textbook has a very nice chart. I think it's on page 2 or 3 of your book. The very first page of this section has a very nice place value chart. So we're just going to practice place value and identify the place value of each 3 in these numbers. And you can go left to right, right to left, it doesn't matter. The 3 over here, we look at the commas. So we're on the 3rd set of place values, and it's in the first place. So this is the 1 millions place. And then the other 3 is in the hundreds place. So you'll have a few homework questions, and it'll give you a number, and you just identify different place values. Then we have this value, 13,400. This 3 is in the 1,000s place. And finally, this value, we have a 3 here and a 3 there. The 3 over here is in the millions, and it's the second digit, so it's in the 10 millions place. And this 3 all the way to the right is in the ones place. So different digits, different place values. Oh, I think I missed one. This 3 here, let's see, it's in the thousands, it's in the middle, so that's the 10,000s place. So you'll just identify different place values of a variety of numbers. The next part of this section is about actually writing numbers using words, which we don't have to do as much anymore. When we wrote checks back in the day, you had to do this more. We don't see this quite as much, but let's just practice writing these numbers that we've just identified place values with words. So this first value is 3 million, and we'll put a comma the same place we see a comma here. This is 456. We have to identify where they are in the thousands. So 456,000. And we'll put another comma. And then the last set is 300. I want to point out that we do not use the word and anywhere in this. The word and is specifically saved for decimals, which we'll get to later. So we do not use any extra words here. 3,456,300. So at first it sounds a little strange. We don't put any ands. We just pause where the commas are. The next value we see is B, 13,400. So 13,000, and we'll put a comma where we see the comma, 400. Not too difficult. And finally, this number over here is a little bit bigger. It has 3 sets, so we have the millions, and then the thousands, and then the ones. So this will be 130 million, then we'll put a comma, 432, then thousand, and we'll just say 3. It sounds really strange not to say and 3, but again, we do not use the word and anywhere in here. We save and for decimals. So just translating the digits into words. And the last part of this section is translating words back into digits. So write the following using digits. 516,009. 516,000, so we'll put our comma. 9 would be 009. And then 306,700,959. So this would be 306 million, so we'll put a comma, 700,000, comma, 959, 959. Make sure that no place values are skipped, so we have millions, and then thousands, and then the ones place. So make sure nothing is skipped. Finally, 77,030,000. So we have billions, there's no millions, we have thousands, and there's no ones. So to be really careful here, anytime we skip something, we need to put zeros to hold those place values. So 77 billion, no millions, so we're going to put 3 zeros there and another comma. 30,000, which would be 030, and that's it, but we have to put 000 because there's no ones. So you have to be careful. Anytime they skip, you have to put those zeros. If this was our salary, we would not want them forgetting those zeros. So just make sure if any place value set is skipped, we put zeros in its place. And that concludes section 1.1. It's pretty short. Hopefully brings back something that's familiar and something you're comfortable with. Hopefully it's not too bad, and we'll practice that a little bit more in class. The next section is about signed numbers, which is positive and negative numbers. And we have whole numbers and integers. Whole numbers have a specific definition and integers are different. So a whole number is any value that is 0 or larger, so including 0, 0 or larger, without decimals or fractions. So no fractions, no decimals. So that would be 0, 1, 2, 3, etc. on up, however much higher you want to count. Those are called whole numbers. So no negatives, no fractions, no decimals. Integers are a little bit different. Integers are any value including 0 and negatives, but still without decimals or fractions. So this time we have all the same values for whole numbers, but we also include the negatives. So this would be like -3, -2, -1, 0, 1, 2, 3, and it continues in the positive direction and also continues in the negative direction. So it really opens up all the possible numbers, positive and negative, but no decimals, no fractions. And so integers include negative numbers, whole numbers do not. And then the book talks about kind of where do we see some negative values. We might see negative values, not really in Houston, but sometimes we see it with temperature. We see negative values. Elevation. I went down in the Natural Bridge Caverns, and we went underground, so our elevation was negative. Let's see, where else could we see negative values? Sometimes with money, we see negative values. Maybe you returned something to the store and got a credit back, or maybe you owe someone money, so it's kind of negative. So money can be negative. There's lots of other examples of where we see negative values. When you're racing, if you beat your previous time, the difference will show a negative value if you went faster the second time than you did the first time. So the book has a lot of different examples of where we see negative values. And on a number line, we put 0 in the middle. We put 0 in the middle of a number line, and we count in the positive direction to the right, and it has an arrow because it just keeps on going, and we count in the negative direction to the left. And again, it just keeps on going. There's an arrow, and it continues. So the positive numbers go to the right. The negative numbers go to the left. And they become more and more negative. So -8 is smaller than -1. To the right, we continue to positive infinity, which is that symbol there. And to the left, we continue to negative infinity. It just keeps on going and counting and counting and counting, more and more negative. So when we draw our number lines, we'll put 0 in the middle, count positive to the right, and negative to the left. And anything to the left is smaller, anything to the right is bigger. So we're going to use that idea to compare integers. We're going to use the symbols for greater than or less than to compare. Hopefully you've seen these symbols before. To me, they kind of look like alligator mouths. That's how I was taught. It's kind of an open mouth, and it opens to the bigger number. Alligators always want to eat more, so I was taught that the alligator's mouth opens to the bigger number. So greater than opens to the left, and less than opens to the right. And that is because we read left to right. So here's some numbers that we're going to compare, and we're either going to put the greater than sign or the less than sign between them. So 1 and 4. If we look on the number line, 4 is bigger than 1. So we're going to open our symbol to the 4. So that says that 1 is less than 4. which if we say that out loud should be accurate. Now we have 0 and -3. 0 is here on the number line, -3 is here. So 0 is bigger than -3. So we're going to open our symbol towards the bigger value. 0 is greater than -3. The next one we have -2 and +5. +5's over here, -2's down here. Positive numbers are always bigger than negative numbers, so we open the symbol towards +5. And on your keyboard, there's these two symbols, so when you're working on your homework, you'll type those in as appropriate. -7 and 0, again, 0 is going to be bigger than -7, so we're going to open our symbol towards the bigger number. Some students say that it points to the smaller number. Whichever way you want to think about that is fine. But this is -7 is less than 0. Here we have -6 and +6. +6 is up here, -6 is down here. If you think about it in terms of money, I'd rather have a +$6 than a -$6. So the +6 is bigger. We open it towards the bigger number. -6 is less than +6. And finally, -12 and +10. Even though 12 itself is a bigger number, because it's negative, it's way down on the number line, and any positive number will always be bigger. So we open our symbol towards the bigger number. -12 is less than +10. Again, if you think in terms of money, I'd rather have +$10 than -$12. And the last part of this section is on absolute value. That might be a new concept. Sounds a little strange. It's a symbol we're going to learn, and you'll see it kind of every now and then throughout this course and your next couple courses. So absolute value is the distance a value is from 0. So it is trying to figure out how far whichever number you're looking at is from 0. Doesn't matter if it's positive or negative, just like when you're driving. If you're driving north 10 miles, you've traveled 10 miles. If you're driving south 10 miles, you've still traveled 10 miles. So that's kind of how absolute value is. It's a distance measurement. How far away is that number from 0? The symbol we use for absolute value are vertical bars. I'm going to kind of overemphasize this. We have two vertical bars. They're not parentheses. They're not brackets. They're just vertical bars. These vertical bars ask the question, how far away is the value from 0? So here we have the vertical bars with a -2 in the middle. Look on our number line, -2 is 2 units away from 0. So the answer is just 2. Not -2. We don't use the absolute value bars anymore. It's just 2. So we just put 2 as our answer. Some students still want to put the absolute value bars, and you don't need that anymore. 9, we have the absolute value of 9. So 9, if you can imagine, is 1, 2, 3, 4, 5, 6, 7, 8, 9 units away from 0. So don't let this be confusing. It's a relatively simple concept. Regardless of if the number is positive or negative, it is that many units away from 0. So this third one is the absolute value of -9. It's still 9 units away from 0. This one always tricks students, and I don't mean for it to be tricky. The absolute value of 0 is 0. If you're at 0, you are 0 units away. The absolute value of -500 is just 500. So hopefully you're seeing this is a little bit easier than maybe you were thinking. It's just the number. No negatives, no more bars, just the number. And finally, 20, the absolute value of 20 is just 20. So absolute value is something that tricks students. They kind of get stuck on what we're supposed to do. Just remember, it's a very simple question. The distance of value is from 0. How far away is the value from 0? It's not trying to trick you. It's just a symbol, and all it wants is the value, no negatives, no more bars. And that concludes the first couple sections of this first chapter, and I will continue in just a little bit.